Hello viewers on YouTube. In this video tutorial, we are going to understand the proof of the chain rule. So let's begin by stating the chain rule of derivative. So it says that if y is a function and it's equal to f of x, and then it's now equal to a function of a function, that is u of v of x. This is a function inside another function. Perfect. Now, according to chain rule, the derivative dy dx is equal to the derivative of the outside function with respect to the inside, that's v of x, then multiplied by the derivative of the inside function, that's v prime of x. So we are going to see and investigate why this formula is true and how it is formed. Now, to prove it out, we are going to consider using the definition of derivatives. So from definition of derivative, if y is equal to f of x, then the derivative dy dx is equal to f of x plus h minus f of x all divided by h. The limit is included, okay? Limit as h approaches 0. All right? I almost forgot that. Perfect. Now, if f of x is equal to u of v of x, what would be f of x plus h? Well, what f of x plus h means in essence is that wherever we see x in f of x, we should replace with x plus h, which in this case will be equal to u of v of x plus h. Perfect. Now that we have everything we need, we can substitute right into this formula. And therefore, dy dx, it's now equal to the limit as h approaches 0 of f of x plus h, which turns out to be this, u of v of x plus h, minus f of x, which turns out to be this, u of v of x. And entirely, we have a division of h. Now, to simplify this, the first thing we are going to consider doing is to multiply both the top and the bottom by v of x plus h minus v of x. And the purpose of this is for us to be able to simplify the limits. So multiplying by v of x plus h minus v of x divided by v of x plus h minus v of x. As you can clearly see that this manipulation is not out of the box because it's just as if we are multiplying 2 by 1. Perfect. So now, from our knowledge in multiplication, we know that when you have something like 2 times 3, then the order is irrelevant, which means you can put it as 3 times 2, as the results will remain the same. This also applies to fraction when you have something like 1 over 2 times 3 over 4. You can always flip the position of this and this and have it as 3 over 2 times 1 over 4. At the end, the result will still be the same, as long as it is product that's connecting them. Perfect. So what I would like to do at this point is that I would like to switch the position of this entire expression along with h. So therefore, we now have the y dx to be equal to the limit as h approaches 0 of u of v of x plus h minus u of v of x, then divided by, now instead of h, I'm bringing this one right now. So we have v of x plus h minus v of x, then times v of x plus h minus v of x, then our h divided by h. Perfect. Now, since the limit of product is equal to product of limit, I would like to distribute the limit for each term. So keep in mind, it's just as if we have in parentheses, the limit is for the entire expression. Perfect. Now to write that, I need more space. So let me get rid of this right now. So therefore the y dx is now equal to the limit as h approaches 0 of u of v of x plus h minus u of v of x, then all divided by this, that's v of x plus h minus v of x. Then we have another limit times the limit as h approaches 0 of v of x plus h minus v of x, all divided by h. Now before we proceed forward, as you can clearly see, what we are having at this right hand side corresponds to the derivative of v with respect to x, and therefore we can just replace it with v prime of x. As you can see, it's the limit as h approaches 0 of x plus h minus v of x, all divided by h. Okay, so now we have to focus more on the one at the left hand side. So now the y dx is now equal to the limit as h approaches 0 of u of v of x plus h minus u of v of x, all divided by v of x plus h minus v of x, then multiply by v prime of x. V prime of x. Perfect. Now, before we proceed more forward as well, we need to do some other substitutions. So what I'd like to do is that I would like to let g be equal to this entire expression, that's v of x plus h minus v of x. Now, if I would like to solve for v of x plus h, then this simply implies or means that v of x plus h is equal to g plus v of x. Perfect. Now, what about the h that is approaching 0? Can we substitute h for g, or can we substitute g for h? We have to be very careful because we have to make sure that as h is changing, we have the right value that g will become. Now, this can help us to determine that. Now, as h approaches 0, what would this expression become so as to determine the value of g? As you can clearly see that as h approaches 0, v of x plus 0, that will be v of x minus v of x, and at the end of the day, g also will be approaching 0, because by the time h is equal to 0, this entire expression becomes 0 as well. So mathematically, we can clearly see that as h approaches 0, g also approaches 0. So we can go ahead and change some of the variables present in this limit. So therefore, we can clearly now say that the y dx is now equal to the limit. Instead of h approaches 0, we would like to make use of g, that g approaches 0. Now u of v of x plus h, we said v of x plus h is g plus v of x, which is the same as v of x plus g. Addition, orders also is relevant. Perfect. Now we have u of v of x plus h, sorry, plus g. Perfect. Now we have the subtraction of u of v of x, then divided by, now we say g should be the entire denominator divided by g. And don't forget to have the product of v prime of x. Perfect. Now let's get rid of some stuff so I have enough space. Now what does this look like? As you can clearly see, this is simply the derivative of u with respect to v of x. As you can see, it gives us the f of, which is f of x plus h, which is f of u of f of v, sorry, u of v of x plus g minus u of v of x, all divided by g as g approaches 0. So therefore, the y dx is equal to u prime of v of x, then multiplied by v prime of x. And these correspond to the chain rule we wrote earlier at the beginning of this video. And this is how the formula is formed. Now, if you are still having confusion or you are still mixing this up, now let's just see the v of x as a. So if a is equal to v of x, or you can use any other variable, you can clearly say that this entire expression becomes a limit as g approaches 0 of u of a plus g minus u of a all divided by g, which is absolutely the same as the limit as h approaches 0 of f of x plus h minus f of x all divided by h. As you can clearly see, it's just a change in parameters of variable, but in the end, they are signifying to the same thing. And that brings us to the end of this video. I hope now you know how the chain rule is formed. In our next video, we are going to consider using those chain rules to solve calculus problem. If you have any questions, feel free to leave it in the comment section below. Thank you. See you in the next video. Bye for now.